Good evening. Welcome back to Rubber Duck Engineering. Hello, Adam.
Special Tuesday edition. Hi, Eric. How you doing?
Yes, I'm well. Tonight we're going to dive into our VMGC, our garbage collector written in Rust for VMs, virtual machines, so that we can wire it up to our Wren virtual machine, which we called SafeWren. And we've made a lot of progress. Well, I've made a lot of progress. Well, we've helped wiring it up, wiring the two up, but we're not quite there. And we're going to make some progress tonight.
Is there any way when you're developing a library to like figure out if it's actually usable, is to actually try using it? Because you find all the things that are like, oh, this didn't actually work. No one could actually use this thing.
Yeah. And that's kind of where we are, is a lot of the usability work. There is some functionality work, some of which we'll probably add tonight. But any news or thoughts before? Oh, news. So it is holiday season, so our times are a little weird. If you're wondering why we're doing on a Tuesday, well, yeah, it's the holidays. We do keep our Twitter up to date with when we're coming out. We expect next week to also be a Tuesday, and might have to.
And we'll see after that.
We'll see after that. Then we really get into crazy holidays. So, but you can check that out. And I guess before I forget, if you want to follow along, the integration branch I'm working on, which is still 200 plus compile errors from compiling, is that one. We're not going to look at the code in great detail in the show now. But shall we look at the VM?
Yeah, so you made a little to-do list for us to look through in this episode?
Yeah, so in the VMGC README, I've been sort of keeping a list of blockers that I've hit. And we can kind of take a pick. So this actually may no longer be needed. I wrote try unwrap. Maybe I should give a little tour of sort of some of the new stuff. So our TryDowncast. So this is a function that can take from an untyped handle or a unit type handle and give it a specific typed handle. I don't know if we had typed handles when we last did our show, but we've added typed handles. So handles now, like if we look at example, it's common for your handle to have a type, which is really nice for Rust because Rust can take advantage of it. It also makes it so that then these handles are really easy to use because you can call as mut. Well, this is on a global one, which is slightly more complicated, but on a direct local handle, which we probably have an example of here. We didn't. Anyways, on a direct local handle, you just call as mut or as ref, and it just grabs out the typed ref for you. It knows what to do.
Gives you access to the object inside the handle with its appropriate type, and then it has no possibility of failure because it knows everything is all guaranteed by the Rust type system.
Correct. So typed handles can never, typed handles that are not the unit type can never be null. We do have some bugs around that where the VM would blow up. I think we can get ourselves into bad situations. I've tried to fix that in the type system. I probably haven't hit them all yet. But so it's really nice to get into these typed handles. And the way you get from an untyped handle to a typed handle is TryDowncast, which this doesn't look like the right TryDowncast.
It looks like the one that actually does the work, not the one that looks pretty. And
yeah, the TryDowncast, that one is probably on heap. Yeah, so here, and one of the things we actually should probably maybe we'll do this episode is that right now TryDowncast only works for host objects. We don't have a good way. There's no way currently to get from an untyped handle or a unit typed handle up to a bool or num type handle.
That sounds important. I mean, it's sort of an implementation detail that we shoved the bools and the numbers as like tagged or nan tagged pointers, right? Mm-hmm. Better if the user didn't have to know about that.
And so I actually don't know how to do that. Maybe that's where we should start, because this is an important blocker.
So what is the trickiness here?
Well, so a naive bit, naively, you would just do this, right? A type specialization, like for F64.
Mm-hmm.
Right, and this
but Rust does not allow. In C++, you could do this. It has like crazy, like template overrides.
Yeah, I don't think you can do this in C++. Maybe with a free function. I don't think you can.
You do like that basically, but that's not legit.
I don't think you can differentiate based on return type, which is basically what we're doing here.
Mm-hmm.
At least I don't think you can do that in C++. You can differentiate on other types, but I don't think on return type. Anyways, I don't know, and someone on the internet watching this will correct me. But as far as I know, you can't do this in Rust.
So, I mean, another way to do it, it's sort of, I guess the issue is here. Like, we know that if this Boolean is true, then we know that this statement is true about the Rust type. So we somehow need to convince the compiler that that's legit. Do you see what I'm saying? Like, let's say we had another function here that did this work. That was like,
one way to fix this is we just remove this host object check.
Well, like, imagine we could do this, right? Imagine we could put this here, and here we could call self.
Sure.
In principle, that would be right.
Yeah, I mean that's basically whether you move it out to a different function or not. You could totally do. You could totally do that, and then add in the additional type checks.
Here's the pass the object pointer,
which is a reasonable approach to this.
I'm just curious if Rust allows this. Like, is it does it matter, or was it happy with that?
What's it sad about? If maybe the missing an else clause.
Oh, we have to return null, I guess.
We can also just map. This is just a map. That's what we're doing. But that's fine. No associated type ID with T.
Oh, I see. Because we really, it's not. You're right. This actually needs to be in here.
Well, okay.
We need some other check here. There's some missing if, right?
Well,
we're trying to see if the compiler will accept this.
Mismatch typed expected unit type.
Oh, we need return.
Trait bound T.
Yeah. So it's detecting that we're calling a function that requires a host object trait, and we don't have it yet.
Sure, because if you say you're calling this with F64, you're now calling foo with F64. You can't do that.
Yeah.
I don't know. Can you have if blocks that like change your type specification?
I mean, it sounds like a thing that wouldn't be safe, right? Like, because it's some runtime invariant of our system that we're then trying to convince Rust is actually a compile time invariant in the type system.
Okay.
I wonder if we're supposed to use the TryFrom trait instead of this downcast function.
I think that would be a totally valid. It could be a reasonable way to approach this. Yes.
Should we try that?
Yeah, we should back this out.
That's kind of the like try in. Yeah. Sorry, you could just undo that stuff I just typed. I think the point of the try into thing is it allows you to give lots of different possibilities for things that you could become.
Mm-hmm. I don't know that you can define. I think you'd have to define them in this. What's going on? Oh, I see. You have to define them in this crate, so we couldn't define them up in, which should be okay. But yeah, let's try that. So this would be like impl try into, I guess.
Or try from, I think is it? I've never remembered, is it try from or try into?
Let's see. It's going to be from. We want to define them on the handle or on the type T. I think it's going to be on the handle. So it's going to be try into T for local handle, something like that.
Okay.
I think. And if we look, I think we have one of these we've already done. Oh,
okay.
yeah. So like I did this one.
Okay.
The to do from should work without error. Oh, well, yeah, this is another thing we could fix is that like we have to figure out how to make into for F64 just work. So what is this? This is try into. But this is not try into F64. This is try into local handle F64, which is a different thing, different but related. But let's go back to our right. So this is try into local handle. Okay, from
right. We want this qualifier here, right? Yeah. And we want to return this here. And we basically want to do this.
Is this one the host object one? Sure. Yeah. All right, sure.
Like that.
So this would then be t : host object.
Right.
All right, why are we sad? Conflicting implementations. Well, let's see. Okay, that implementation, and what's our other implementation? Oh, do we have a from somewhere?
Oh, let's do this.
Conflicting implementations of try into heap handle, local handle for local handle. Oh.
What does it conflict with?
Where you standard convert, it's some like.
Oh, I think it's supposed to be TryFrom. I think you want to implement TryFrom. The other way, you just want to do this the other way around.
Oh, I see. And since we're wrapping the T, this might work. Okay, I'll try. TryFrom. And does that consume? Does TryFrom consume?
TryFrom.
I'm looking it up.
Yeah.
This is the TryFrom consume. Why is it?
I don't know the difference between TryFrom and try into is.
It doesn't take a self.
Oh, right. It takes a T, right? It takes the thing you're coming from. So it takes a handle. It gives you back self, which is the thing. This is not self. This is this thing. Comment this out. This is going to cause freak out pretty bad.
Okay. Missing generics for trade. TryFrom.
Oh, okay.
That's from it.
Oh, I took it away. Sorry, I didn't mean to take it away.
Okay, what are we doing? Conflicting implementations.
Okay, so it was unhappy either way.
What is it? Core. Impl T, U.
Okay. Oh, where U is into T. So we did too many intos. We have an into messing with us.
Yeah.
This one, maybe? On line 340? No, that's heap handle.
Let's see, what do we got? Well, again, this is a handle. Let's see what this says from. roll handle for heap handle.
Okay.
TryFrom. This is the one we're working on right now.
Yeah.
Local handle for heap handle.
Local
Local handle, roll handle.
These are tag pointers.
I don't see anything that. Conflicting implementations. Impl t comma u TryFrom. Should this not be a try? Okay, we just need to look at the docs.
Okay.
How to implement TryFrom Rust. Okay, Rust by example. You're supposed to. So I wonder if the right-hand side is allowed to have a type or a TryFrom. So the example it gives is TryFrom I32 for even number.
Can you project that on the video so we can see it?
I can try. We'll see what my fancy projection technology has here. What do we got? This. Yeah. Okay.
For even number? Okay, even number is a thing.
Like, I wonder if we need to import the standard convert, but.
Oh, standard convert. Try. No, we imported that. That's good.
I don't know about this, like a generic TryFrom here.
Okay. Should we try to make a reduced test case and see if we can figure out the problem?
Yeah, like I suspect if this wasn't handles, well, I don't know. Let's see.
Like, what if we just made this like list in particular, and see if that would cause a problem? Well, let's keep this around, right? Because that's where we're working from. And let's just say like that's where the old host object.
Mm-hmm.
List. Okay.
These will continue until morale improves.
Okay. Is it still mad?
Missing generics. Oh, that's because the list has generics.
Okay.
Maybe you want just string.
Okay, string. Yeah, string is up to the list. Okay.
Okay, it liked that.
Okay, so the problem is somehow the type parameter. That's a bummer because I kind of want to do it generically.
Okay, let's see. Generic TryFrom Rust. Experimenting with generic TryFrom troubles occur.
Oh.
I don't know, just add a Rust user Lang.
When in doubt, search the internet for the answer. It'd be a bummer to have to write all these out. Like, it seems like the generic should be able to do it.
I don't think this is impossible.
Another possibility is we just make our own trait. That we don't have to reuse TryFrom particularly. Like we can just make like a Downcast trait.
Here is a play Rust.
We can't see what you're looking at.
I know. You in private chat, and I will also pull it up in. I need like a whole studio for us here. I want to press the right buttons to share the right screen. So I got a fancy new monitor, as you know, and I think the internet now knows.
So many Ks. Many
so
Ks.
many Ks. And so I have literally 4 tiles.
So is this code, does it work or does it not work?
This does work.
Oh, okay.
Somebody wrote this as a response. It's like, this should work. So like, we just run it. What does it do? Unreachable pattern. What? We're in dead code.
Oh, that's fine. It's got some dead code. Okay.
Feature TryFrom is stable. No longer needs.
Where T is try. Oh, look at this. TryFrom parse component. Huh?
I'm working to update their code here.
Error. U is TryFrom. These are a bunch of different TryFrom types. Oh, I see. This is like a delegating one. It wants to call try and do a bunch of times.
Yeah, this may have actually nothing to do with our problem. It just was the first hit.
Yeah, I think this is not the same because there's no. Oh. Yeah, I mean, this is. I would expect this to work, but I also expected what we wrote to work.
How do I implement TryFrom generically?
I think we just make our own type, our own trait that's called Downcast, because we don't necessarily want to involve the TryFrom machinery.
Okay, this is from 10 months ago. You can't write a generic implementation like this unless something changes in the language. The error points, there's already a blanket implementation core. It covers any type for which implements into of that type. If you added your own blanket impl, then any type which implements into iterator item would have multiple conflicting. Okay. So this is, this looks slightly better as we continue to do Googling here for you. I can show it since I'm in web browser mode. This.
Mm-hmm. All right. Do they give many good suggestions? I think we just make our own Downcast trait, and that will avoid all of these conflicting definitions in core.
Sure. That seems very straightforward. Stop screen. Share. Keep. Okay.
So, Downcast D. Downcast to D, right? You don't need this anymore. Downcast. Get self. And you get back an option.
Okay, why so generically? This should be written in terms of handles. That's the whole point.
Well, now we can do it for all of our fun handles. So now we can implement it. Implement.
No, I'm just saying you can do handle T, right? Oh, I see. For all the different handles. Okay, fine.
Downcast 2 from unit. Okay. So this can just be self. This can be T. Let's transfer back into T's. This can be none. And this could be self dot
You want this to be option or result? I guess you want option.
Some. Option. Yep.
Makes sense.
we can get rid of this.
Okay, and we change this from self. Oops.
Mm-hmm.
Is intended to be consuming.
Might as well. Local handles are copyable, so.
All right. So now this takes 0 global arguments.
Takes 0 global arguments. Oh, you don't need the yeah.
Well, okay. How are we going to express?
Okay. That seems not good.
Well, so we could go back to.
Oh, I think you express it with the like the type you want it to be as. So like, let me try to follow you. So I think you can do this, right?
Or you're also going to need to write, because of the way you wrote it, you're going to have to write it. I think your TryDowncast is going to take local handle string, which is not what you're going to want.
Oh, do we do it backwards?
Well, you're going to end up wanting to separate out. Like, I think you're going to want HT.
What?
Well,
You always want a downcast from unit, right? You never want to.
No. It's you don't want to type local handle. Maybe that's implied.
What do you want instead? Oh, you want the actual string?
When you type this, where it was that we were working on that example, this thing. Okay, well, let's just see where this is going here. Expected struct.
Oh, this is
this is supposed to be unwrap.
Well, this is testing that it's none, so unwrap is going to crash it.
Yeah, you're right.
Yeah, so
is that saying that's working?
That's working. So this is now, let's just rename this. This is now how you specify the thing that you want. I don't know whether you like this ergonomically, but.
I mean, you still would rather, if you could, type string here. Right, because then it can infer the local handleness from the untyped thing, right?
But I think that this is what's getting you in trouble. I think that like Rust doesn't have the I forget what this is called in C++, but it can't resolve which method you want. Like you want a more complicated method resolution than the fish operator can give you.
Okay.
Which I think is why TryFrom is done this way.
I still would. Okay. Yeah. Okay. Sure. I mean, we can try this. See where it gets us. Okay. So TryFrom we're done with.
So we can do the
why
other
do we no longer have any? Oh, because we left our.
No, it showed up there. Oh, sorry. What is the question you're asking?
The TryDowncast that we had before, we emptied it out, but we didn't actually delete it.
Oh, I deleted it. Yeah.
Oh, you did delete it.
Yeah, secretly while you were watching.
So why did all our errors go away?
We fixed them all. Where else is TryDowncast used?
All over the place.
I mean, the rest of them work.
Okay, fine. Maybe not all over the place here. All over the place in the other code.
Yeah, I think when you go to the Wren GC, this is going to take some adaptation.
Oh, I see. You did. Okay, fine.
Can we try to do the, so the reason we do this is to do float, right? So let's see if we can do that.
Mm-hmm. Well, that I know you can do because I've done that pattern. But yeah, let's do it. I've definitely made this pattern work in other
ones. You know how to write it? Like what? Right here.
Yeah, I think I've even written this exactly. You just basically do. Hold on, F60. I literally have this code written elsewhere, but we can also just write it from. It's into this one.
Oh.
Yeah, basically.
Oh, how's that not the same as what we were trying to do?
Well, this is changing it into an F64 as opposed to a local handle to an F64. It's very similar.
Oh, I see. We just need to dress it back up as a handle.
Sure. I mean, you could use this. Well, this gives you back a result, GC error, as opposed to a. Why is this? I think I'm spending more time looking for it than I would take to write it. But so back to our TryDowncast here. So what is it we're going to return? We're going to return this.
Mm-hmm. No, we're going to return we're not going to actually make a new index.
Why wouldn't we?
Well, we just have to make the scope do it. Like you're doing a bunch of manual work here.
Well, we don't
just want to do.
Oh.
Create num.
All right. Sure. So then
self.try into dot. Okay.
Oh, okay. That's an interesting way to do it. Okay. I mean, that's certainly a way to do it. And you can do that for bool as well.
Yeah.
I have no idea if that's the most efficient way or whatever, but sure, it works. Try into is not built for that, really.
Oh, we should just add that. Whoever got that. That was local handle, right? Local handle.
You have to go find it again.
It's this one here.
You found it, yeah.
We just want the same thing. And this sort of explains why you don't typically want this, right?
Because you don't want to try into a.
Well, you want to get the primitive out, right? You don't actually want to get the handle out. This is fine.
Yeah, I actually don't know. Well, here we have into bool. Clicking. Oh, maybe this is why I didn't, because we have into bool here.
That doesn't seem right. Like.
Well, this is into bool for.
Oh, if you have local handle bool, sure. Right, and so you have into float for. Do we have into F64?
Yeah, I ran into this before as well, because you get the same problem that it's making an inferred. It's making an inferred try into, I think, from this into.
Okay, so what you're saying, if we do this, it's going to be mad?
Mm-hmm. Yep, they're both going to be the same error.
I see. So maybe we just don't have these.
Well, you're going to, like...
But this is really, there's no T here, right? Why isn't this just from unit? You never want to.
Oh yeah. Oh totally. I agree.
So now they shouldn't conflict because they're totally disjoint types.
Yep. That was the whole problem. You don't actually want a T.
Yeah.
If yeah.
If you have the typed handle, you can get the value out all the time. And if you,
I've been slowly learning that here in other contexts. There's a few more in this same file, like right here, like is null. That only ever makes sense when you're the unit type, right? And a race type only ever makes sense when you have a non-unit type.
I see.
Well, actually, that's not actually true. I make it for, oops, I make it for T. But like there's a fix me here that I don't think we can yet remove set pointer. That's fair. Here's another example where a keep handle unit type, it's safe to take from. You can ask it if it's null. You can ask it if it's a number, but otherwise those questions don't make any sense. Right? But this is currently on generic, and I think we might use this during collection.
Or during like initialization or something.
Let's see where we use it. We use it during take.
But take is also just.
But take could just manually do it, and we use it here, which makes no sense. So I think we can just remove this.
Okay, try removing.
Set pointer is a foot gun.
Yeah.
You never want to do this.
Right, because it's type unsafe.
Yeah. So we just put this. This, I don't know what we're doing here, but this is not the way that this needs to go.
Well, that's fine. The out handle is yeah. This does not need to do this. Out, just say out equals. Yeah, this was like the first add function we wrote before we had any idea what we were doing.
Had none. We were whatever it is, bear knives and
bearskins. We were taking rocks and smashing them together and be like, look, we added numbers. It's great. We could add some numbers.
All right. Okay, we're making significant cleanups here. Okay, what's this going on? Heap handle from F64.
We should say heap handle new, I think, there. You still need the into, because you gotta turn the floats back into a tag pointer, and then wrap them up as a heap handle.
Oh yeah, okay, fine. Oh, this is still wrong. Like, you want, like, this is not how you add numbers. You just never want to deal in. Like, I removed push pointer from list because that was another foot gun you never wanted to use. What's this doing?
More fish probably.
No, it's not fish. It's missing an what?
This one reference.
Ref? Oh, we want.
Oh, star. Yeah.
No. I'll do it because it's legal and that's the way this code was written. But no.
Well, it's an improvement. We can keep iterating on it for sure.
Yeah, I think the way that I haven't actually written this part of the code yet because I've commented out all the core. But I think the way I'm probably going to do it in a first naive pass is to just return local handles. Pass in the scope.
But this is vastly faster than returning a local handle.
Yeah, and so
yeah.
But you don't have the safety of like, what if you forget to set the out parameter?
Yeah, I mean, you often get like a safety performance trade-off. So, but like adding two numbers, you don't want to have like call extend on your vector, right?
Yeah,
you just want to add the numbers.
All right. So where are we with this? What did we do? How did we
added the ability to downcast to floats and bools, which seems useful. It was on your to-do list. Do you want to go back to your README and we can see if we can cross off one of your README items?
Dun, 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 dun.
Or like primitive bug list, that's the README.
So what is actually happening is that in my limited free time, when I'm not actually working or spending time with my family, my fun thing is to do this conversion. So I plod forward, another few errors every night or whatever. But then I hit these walls and I need to, come talk to you, which we don't always get to do. But this now unblocked, I expect another 100 errors or whatever. But yes.
It was like plan for trying to num. We did that one.
Well, this one's done, I think. Example of try into for. Yeah.
Yeah, we just did that, right?
Right. Let value, constant value. Yeah, I think I had already. Okay.
And this one we just did, right?
Trying to num. Yeah, that's done.
Yes.
We could evaluate whether this makes any sense. I ended up just passing the scope down in order to make the null.
Okay.
But it was sort of silly. It was like a thing wanted to pass a null heap handle. Is there any value in a freestanding null?
I don't know. I mean, if you're happy with the way the code is now, I would try to fix things that are blockers, and then we can return to this if it becomes a blocker.
This we talked about in the green room about how to take a list. Oh, we were going to do, like, we have this take, we could do give.
Yeah, okay. Do we give the context of that one and talk about it?
Yeah, so this is listed down here. So there's a few places where if we pretend for a moment that this object is traceable, then this can make sense, right? Where you just hold a list directly instead of holding a heap handle or a global handle or something to the list. But sometimes
it's the VM's responsibility to trace the list.
Yeah, and again, VM may be the wrong, but this is like some object, right? It like wants to have a list inside its object. Like, for example, an example of that is like obj function, like keeps a list of fields, right? That's a thing. But say you wanted to like start with some of the field set, which is actually like a warning that I know I need to fix. And like this is obj. So how do you do that? We don't have a vec.
Yeah, so specifically, it's valuable to build up the object in the scope in case you need to garbage collect before you actually end up creating your before you end up creating the object that's going to hold it. It makes sense to hold all the pieces in the scope in case you need to garbage collect in the middle of your construction.
And here
right now, we don't have this give function. Yeah.
The way this actually would be written with this would be impl obj fn. This would be.
This is like the new function or whatever. It would take a scope.
This is the new function, right? New, and this actually returns a local handle. A lot of these, by the way.
Yeah.
Right. And this takes a scope. Handle scope. Which, by the way, sometimes it needs the lifetime of the borrow, and sometimes it doesn't care. I think it's maybe when you use it that it cares.
You have too many A's, but that's fine. I think this is.
Oh, really? You don't need that second A?
Those are two different things.
Yeah, but in most of my code, I'm typing both of them because I lead with this one.
Okay.
And then sometimes it'll say, oh, you're missing this one.
Okay. I mean, you could probably, if you ever need it, just go like that. The borrow, this is the lifetime of the handle scope object, and this is the lifetime of the heap, the whole heap.
Oh.
Yeah, because the heap keeps these like stacks of handle scopes.
Yeah.
And then we use the Rust lifetimes to ensure that you free the handle scopes in the same order that you created them.
But this is the lifetime. This here is the lifetime of the. No, this here is the lifetime of the handle scope. That's what this one is.
Yeah.
Ah, okay. So this is probably actually bogus, and I can go remove that.
But I think we're trying to make this give function. Like this seems like a pretty sensible constructor. Like create a bunch of temporaries, like construct your object. When your object is fully constructed, like give it over to the heap to manage.
Good. I'm glad you like this constructor because I've written a whole bunch of these.
Well, it's a very like rusty way of doing it, where like because in other languages, when you write constructors, the object exists and then your constructor runs to like populate it. In Rust, it's the other way around, where you generate all the pieces of your object and then you build it and return it from your new function.
Okay, so let's write give, because that's another piece that's missing. That's only a couple errors, but those are some ones that I didn't see. A good path passed.
All right, let's try it. I presume it should be somehow dual to take. We sort of suggestively called it give to have that idea.
Let me just commit our TryDowncast before we break the world. TryDowncast. Oops. Commit to main. Okay. Those following along at home, it is pushed. Okay.
So it'll be on scope, I guess.
I think it's on both, but yeah.
Here's take.
And place.
Right. So give.
So we can write the signature. You want to write it? I didn't mean to take over. This is.
I'm trying to think how this is going to work, actually.
I'm sorry?
I'm trying to think how this is going to work. But go on. So at the end of this operation, you want Russ to have ownership of the object again. But there could be any number.
You're going to have this handle that. What are you going to have done to this handle?
Yeah.
Like, because it's a typed handle.
Mm-hmm. Or like even more precisely, like this thing used to exist in a heap, could have any number of pointers pointing to it, and now
you ripped it out.
You ripped it out.
I don't think that's. I think you have to copy it out.
You want to copy that?
I think you have to.
Well, another option, I don't think it's a good option, I'm just putting it out on the table, is you could make that thing behave as null now. Like you could say this is now a null object.
But you can't. Not with a typed handle. You violate the contract of the typed handle, which may not be a viable contract. And that's another thing you and I need to talk out, is that we've made these handles, these typed handles, theoretically non-nullable, but I'm not actually sure they are. Are they strong pointers or are they weak pointers?
Which?
The handles. I think they're strong pointers.
Well, the global handle, yeah, they're all strong handles.
And so you can't rip anything out from behind them. That would not be cool.
Okay. So let's just consider other options. So instead of calling create, when you created your list, you could call some other function that's like, hey, give me this temporary list where I want you to trace this for now. And then later on, I'm not going to, like, no one else can make any pointers to this thing, but you're going to keep it, like, connect it to the heap for tracing. And then later on, I'm going to sever it from the heap and I'll take responsibility for tracing it. So it never gets into the heap, but it's somehow traceable.
I mean, we could also, yeah.
So imagine like somewhere in here, there's like box into raw or whatever. So we never call into raw for it. We never allocate any space in the heap for it. Mm-hmm. All we do is we know that it's a traceable object, and the handle scope, let's say, keeps a list of option traceables. It's like, hey, here are the traceables that I'm responsible for tracing, at least temporarily.
Why don't we just copy the things out? Like, why don't we create a temporary list and move its heap pointers over?
We could do that.
I mean, like, these are all about list initialization, and they're all instances of vec.
Okay.
I'm just wondering if that we're solving a problem that isn't actually real. Like one of the fields one I have to just fill with null. Just like, okay, fine. It used to be vec null, vec value null, comma, the number of fields, right? And they would like splat out a field with that number of value nulls. And then the other one is like, I have to initialize the stack with the closure on the bottom of it.
So I think is list clonable? Because then you could just clone the one that exists in the heap to get a new copy of it.
Is list clonable? List is just a vec. It's just a.
You use it as a question when you declare the clonable trait. Right. So I would just stick clone on that drive.
And then we just clone and take?
You don't have to take it anymore. You just basically get a reference to the one that's in the heap. You're going to clone it, and that's the one you're going to return. And then let the one in the heap get garbage collected.
I see. You just as ref clone. Okay. Yeah. Okay. I can make that work. So I think those are unblocked, or they're small enough to not matter. Let me see if there's any other big things.
Should we just update the README with that fantasy code? Because then I think it's just list
list.asref.clone. Yeah.
But we can do the other thing if we need to, but we should wait till we actually need to.
Yeah, I agree. All right, let's see if we look at anything else. Guide the preferred order. Oh, so that's another thing we could do. I don't know. We don't have very much time. We could talk through what this means. So right now, I generally don't pass local handles by reference. I pass them by value. So you just you copy a local handle when you pass it in. That seems reasonable.
You should just always do that. Like all a local handle is a pointer and an integer index. So copying it is like no problem.
Okay. I tend to return references to heap handles when I am like returning them out of like a vec or something like that. I sometimes pass in heap handles, and in fact, you currently see that. And I meant that them always be referenced to heap handles, but sometimes they aren't.
Okay, so I think it's very dangerous to have so heap handle has no connection to the heap. Sorry, has no connection to the tracing mechanism.
Yep.
So if you ever have like a local variable that's a heap handle, there's a risk that if you garbage collect, you won't trace it.
Yep.
And so this function signature here is dangerous.
And we aren't doing this yet, but like in a future episode, we'll probably fix this on an episode. We will add the ability to collect during allocations, and we'll add the debugging ability to collect all the time. And so hopefully we'll catch some of these.
Yeah, we haven't actually talked about what the right invariant is here. So for a single-threaded, it's fairly easy. You just say the only valid collection points are when you allocate, but if you're having to do a multi-threaded heap, it gets more complicated because some other thread could be the one doing the collecting. And so usually we do these like safe points where you say, okay, I'm going to basically take a lock on the heap that says I'm vulnerable right now, you can't collect.
Yep. But so I think I did this in another change where I changed these and then the world got sad.
I think that these are not necessarily bad. Like these actually look fine to me.
Oh, just because the methods are short.
Right, because this is saying function is like the push function has to guarantee no heap allocations, which is fine for the way we've currently implemented vec. If we made vec into if we stored its actual vector in the heap, then we would have to worry about this more.
If the fact that you can write the signature makes me worried that we'll accidentally do it. I don't know if that's possible to prevent in Rust.
I searched a little bit about if you could. So in C++, you can make non-movable types.
Mm-hmm.
I looked a little bit. I couldn't find a way in Rust to make a non-movable type. But the...
You're telling me I don't.
Yeah, maybe there's some way of doing this with lifetimes, where basically you tie the lifetime of a heap handle to some traceable object.
Mm-hmm.
And so the heap handle has to both keep its value and remember what traceable object it's related to. I bet there's some way of doing that.
Interesting.
And then you wouldn't be able to construct a local heap handle because it wouldn't somehow be associated with traceable object.
That would also fix this other bug where like you can have a heap handle and put it on an object that doesn't happen to be traceable. You could forget to make the object traceable.
I don't think you actually want literally a pointer back from the heap handle to the traceable object. You somehow want the like lifetime accounting of that without actually having the storage for it. So I don't know if in Rust there's a way of taking a value and like putting it in a container that makes its storage go away, but like keeps it.
It's like phantom type or phantom data or whatever, right? Phantom data might do it.
Oh, should we look at that? Maybe it does. Yeah, it's kind of what phantom data is all about.
You want to launder the lifetime out of the type somehow.
Oh yeah, I guess you could do phantom data where your the thing you put in the phantom data has the lifetime.
Well, like you need two phantom datas, one for the like host and one for the type.
Should we? I mean, I don't think we're going to. We could try to like type an example of it. Like
that is a can of worms with 3 minutes left, sir.
Can we do it just for like not for heap handle, but for another object, just to see if that idea is possible?
Sure. Where are you typing?
I was going to go find the definition of heap handle and type it next door. Yeah. So I'm in object.rs online. Yeah.
Okay. I tickled your.
Well, lifetime. The fact that you can hold lifetimes as these little variables is really powerful. So then we already have a phantom data in here. Oh, that's a different phantom data.
But that's the phantom data of the
okay. We'll get there. So then I want more phantom.
Well, you could just say this. This is the like one's this is the object, or this is the pointee. Yeah.
Data. Does Rust accept that as a declaration?
It appears to.
Wow, I think that'd be kind of neat, actually. Then, like, that basically will prove that every heap handle you have is associated with some traceable object.
Well,
I'm sure you can still write bugs, but it will make it.
Well, okay. So how would you use this thing? So say you have your struct foo here, and you want to put a handle in it.
Yeah, I see where you're going here.
It's going to be a fake heap handle foo. Sorry, the foo string. Oh, and you also are going to be sad.
No, you don't need a foo. You can see that. Use a.
Okay.
I don't know. I don't think that's a complete thought.
It's an interesting thought.
I don't think it's this. I think it's like, is there like a self? Like, you can get your own lifetime.
I feel like we need to like pull a member of the Rust core team onto the.
We may be abusing lifetimes way too much, but it's something like this sounds sort of plausible direction for exploration.
All right. Well, we are out of time. It has been fun as always. There's definitely going to be progress now that I'm, unblocked a ways more. I'm going to delete this if that's okay.
That's okay. It's a dream. We can have the dream again sometime.
It's a lovely dream. So next week we expect to be on Tuesday again. But as I said at the top of the show, what is it all the cool YouTubers say? Like, subscribe, mash that something button. Anyways, the Twitters, we post on the Twitters when we're going to appear.
You can also subscribe, and then YouTube will notify you. Just saying.
Oh yeah. Well, I don't know how much warning. The 20 minutes before when I set up the show, but yes.
Yeah, I think the ultimate goal we're requesting after is once we integrate this into Wren VM, we're hoping to see the benchmarks improve. And
yeah,
so
well, I think we're going to have
couple weeks we may be able to actually measure that and see if we've done that.
I hope so. I hope I'm like 150 errors away at this compile phase. I'm sure there's probably 150 compile phases and 150 errors each compile phase, but I'm hoping to have it running in the next week.
Yeah, I'd be really interested to get to like the performance tuning phase of this, because that's sort of the point of why we did it, was to make the benchmarks go faster.
But there's quite a bit of typing before we get to the performance tuning. We're going to get to the crash tuning phase for a while first.
Is this just the progression? Like, does it compile? Does it crash? Does it go fast?
Rust normally lets you skip that first one, or the second one.
Does it crash? You
spend infinite time making it compile, and then
it doesn't crash, except when you have unsafe all over your heap, and you find all the actual problems.
So, anyways, it's been fun as always. I'll see you next week.
Yeah, see you next week.